Algebra 1, this is 1.4, distributive property. So the distributive property allows us to multiply numbers or things into groups. And so majority of the time when we use the distributive property, we will have a monomial, a single term, outside of a group. This is where we would consider distributive property, where we have a single term outside of a group. And the group actually can have 2 terms, 3 terms, 5 terms, 10, 20 terms. It doesn't matter. What we have here is something on the outside that needs to be multiplied to everything inside. Now this is not the only way we're going to see this. There are a couple different ways, but they kind of all work the same way. Now, if you see it this way, what we're going to do is we're going to distribute or bring in that a on the outside using multiplication. So I'm going to multiply a times b and a times c. Now, I know I just put 2 little rainbows on here right away. 99% of the time, I'll never put the rainbows on all at the same time. I will try to break them up and do one thing at a time. Because what this ends up equaling is a times b, which was our first rainbow, plus a times c. That is the distributive property in practice. And of course, these things all can change. We can change it very slightly if I still had the same quantity, but if I put a in the back. At this point, we can go all the way across to here and say this is b times a plus c times a. Now remember, since multiplication is commutative, right? A times b, b times a, doesn't matter. They're the same thing. They're the same value. And you can add numbers in any order. So technically, these 2 groups here can be switched as well. That's if it was added. What would it look like if it was subtracted? What happens if I had something like a times b minus c? What would this look like? It'd be a times b minus, because it's a times a negative c, or minus ac. And of course, if they had that group first, I can distribute the a from the backside. And so therefore, those are the 4 different ways using the same concept called distributive property. Okay? So, try this one on your own. 3 times the quantity of x plus 4. This would be using the distributive property. So to do this problem, 3 times x, which equals 3x, and we have 3 times 4, which would be a positive 12. And so the answer, when we expand it, this is called expanding as well, using the distributive property, I get 3x plus 12. Probably not too many questions. Now, what happens if I asked you to do 7 times 49? What if I asked you to do 7 times 49 and I say, you're not allowed to use a calculator? Whoa. That's a big number, Mr. Konchak. I don't know if I can handle that. You can handle that. You can handle this using the distributive property. Think of ways to make 49. How can you make 49 using addition or subtraction? What nice numbers make up 49? 7 times 7, yes, but that'd be multiplication. What if I want to use addition or subtraction? What numbers add or subtract to get to 49 that are nice? I mean, 49 itself is fairly a nice number, but Would you guys be okay with 49 being 50 minus 1? Is that the same thing? Can you multiply that by 10? Would that change anything if I distributed the 7 in and then gathered like terms or simplified at the end? It shouldn't. This is how the distributive property can be used to your advantage. It can be used for the fact that I can take a number and split it inside of parentheses, because order of operations usually told us 50 minus 1, which is 49, multiply that by 7. That's the original problem. But now that we know this distributive property, I actually am able to multiply through a number on the outside before I do my other operations. So again, it's kind of going back to that order of operations stuff and making things a little wishy-washy. And here's the thing. The reason I think 50 is okay is because you get a 0 at the end. That means it's multiplied by 10. 5 times 10, right? That means I could take 7 times 5. And most of us, if not all of us, we should know what 7 times 5 is. What is 7 times 5? 35. It's 35. It's 35. So when I multiply these two, I'll get 35. But then there was that 0, which means I add the 0. So it's 350. And what's 7 times 1? It's minus 7. And what is 350 minus 7? That equals 343. We never used a calculator. That's really cool. Try this one. 304 times 15. Which number looks to be the scarier number? The 304. So can we split 304 up into two nice numbers? What would they be? What nice numbers would you like to multiply 15 by? So this thing's going to be split up, and we're going to put a 15 on the outside so I can multiply it in. 304. How can I split that up? You can add numbers together or subtract them to get there. What kind of number is kind of by itself in 304? 4. So if I had a 4 there, what would the other number have to be to make it a 304 together? Then I'd probably add them together. 4 plus 300, right? Or I'll put 300 first, plus 4. It really doesn't matter which one you put first. But 300 plus 4 is 304. Times 15, you get the same answer. At this point, I'm going to distribute through. Now this problem has 2 zeros at the end, right? So all I have to do is worry about what's 3 times 15, add 2 zeros. What's 3 times 15? 3 times 15, 15, 30, 40, 45. So it's 45, add 2 zeros, plus 4 times 15. So now we're at 45, that was 3 of them. Add 1 more 15. Or 15 plus 15 was 30.
60.
So it's 60. So what's our number? If I add those two numbers together. 4,560. Done. So the next part is like terms. Like terms contain the same values, or not the values, contain the same variables with the same powers and powers. If you don't have the same powers on a variable, they're not like terms. Hence, if I had something like 2h squared, I can add that to 3h squared because they're dealing with h squareds. 2 of something plus 3 of something is what?
6.
We're adding. So it's 5. So they're 5 of something. What was the something we're talking about? They were h squareds. Now, this works great. X squared plus 4x. Are they the same thing? No. They're not the same thing because one's an x squared and the other one's an x. They're not like terms. So you only are allowed to put things together that are exactly the same. And what we're doing then is looking at the coefficient. And remember, coefficients are the numbers in front of all of the variables. Something that they may try to trick you up with. So this does not add up, or not like terms. Maybe I don't want to cross them off. Not like terms. What we want to do is say, hey, we could have a negative xy, and we could add 6xy. These are like terms. Y, the same variables, x and a y together, and they both have a power of 1. So these technically are like terms. And if I have a negative 3 of them, and I add 6 of them, how many of them do I have? 3 of them. And them are xy's. Okay? These are like terms, and we write it in simplest form. And when we say simplest form, we want all of the like terms put together, and you get rid of all the parentheses and all of those things. And so, let's take a look at a problem. What if I asked you 4y cubed plus 2y minus 8y plus 5? Can you put that in simplest form? So, what are like terms? Are there any y cubes in here? Just the one term. That means there's no other like terms to it. You're stuck. You have to bring it along for the ride. It stays. Notice, though, that the two middles are both y's. And that means I can put them together. What's 2 of them minus 8 of them? Or plus a negative 8 if you want to go that way. What's 2 minus 8?
Negative 10.
All 3 answers I don't think were correct yet.
2. Wait,
I liked the 6.
negative 6.
It's negative 6. Because 2 minus 6. If you have $2 and you have to give someone $8, that means you owe them 6 yet. So 6y. And then you look over here at the 5. That's a constant. Are there any other just numbers laying around? No. So it goes along for the ride. And you just gathered up like terms, which means you also simplified the problem.